Welcome to the third video about pandas, and we're going to go through a collection of more advanced operations on our data and a few bits and pieces here. So we've gone through some basic plotting and selecting and subsetting our data. Sometimes you do a bunch of processing on your data frame, and you want to take the result of all that processing and save it so that you don't have to do all that processing again. So maybe you're reading a CSV file and you want to save it to a more efficient format or another CSV or something like that. In this case, we're taking our trip data that we created in the previous steps, and we're saying we only care about the start station and end station columns. We only want the first 10 rows, and then we're going to save this data to a CSV file. Right? And Pandas has lots of utility functions for writing feather files and CSV files in various formats. So depending on the nature of what you're doing, whether it's saving a CSV file for use in a lot of tools or feather for much more efficient storage, that's what I would recommend for storing something for reuse later. If you happen to be writing LaTeX, Pandas can take a data frame and write it to a LaTeX table, which you can then include directly in your thesis or whatever. This can be really useful if you're creating tables of data with analysis in Pandas and then you want to include those directly in your thesis. You don't even need to copy and paste. You can write this to a text file and then use an include directive so that it's automatically updated and you don't have to deal with things getting out of sync. And now we're going to get into some more detailed analytics of working with our data and joining multiple sources of data into one analysis. So here we're going to take, like we did with the plotting, value counts lets us do things like find the most popular values in a column. So this is taking start station and then excluding the top 10 results and giving us the rest. We can also do the same thing of take value counts, take the top 50, make a bar chart with that. So these are our 50 most popular stations, and then plotting the number of trips that started at those stations. So if you think back to the data that we had a collection of CSV files, one for each month. So we have been working with the data from October, but we are going to load additionally another one of our files, which has data from September. And we're going to do the same processing to get end station to be an integer by discarding the few trips that don't record what station they end at. So now we have two data frames, one for September and one for October. But it's not actually important to us that we have one Python object per file. We actually just want one data frame. So what we can do is we can call concat to concatenate those 2 months worth of trips. And then we use reset index because each data frame will have an index that starts from 0, and we want to reset the index so that it goes from 0 to the total count. So now our trips is the concatenation of September and October. And now we can see the range of times goes from the 1st of September to the last day of October. And we can see the total numbers are, we have 300 some thousand in September, 200 some thousand in October, and 600 and some total. So as it gets colder and wetter in October, fewer people take their bikes. That makes a certain amount of sense. So right now we have this data about when trips start and which station they start and end at. But we don't actually know where those stations are. We just have their integer IDs. But fortunately, we have another source of information that is currently stored in a JSON file that has information about each station. So they use the same IDs, and it has information about them like the name of the station, an extra name, extra information, a longer name, number of bike locks, whether it's in service now or not, and its GPS coordinates, its latitude and longitude. And additionally, it has a shape. So this is a polygon in latitude and longitude for drawing it on a map. And we have this information about all of our stations. So this, unlike the CSV, this is similar data in that we have a sequence of records with named fields, but this time it's stored in JSON, and like CSV files, Pandas knows how to read JSON files. But it's not quite magical, right? Pandas can't always automatically infer the structure and type of any arbitrary JSON file. And so here, if we just say, Pandas, please read this information as JSON, it doesn't quite work. So what we do is we load it with JSON ourselves, with the JSON module in the standard library. And we can see we get a dictionary with one key, and that's stations. So we actually want to extract the stations from the dictionary. And now that is a list where each item in the list is a dictionary. And this is more like what Pandas expects. And now we can use Pandas JSON normalize to read each record in that list. So now we use JSON normalize, and we get a data frame where the keys in the dictionary have become our column names. So where these are simple, and structured. Center and latitude and longitude became center.latitude and center.longitude, right? Because Pandas needs to have a flat hierarchy. So it expanded center because everything has a latitude and longitude. But bounds it didn't understand, so it kept bounds as a Python object. So this list of dictionaries was preserved as it was. So, but number of blocks is an integer, in service is a Boolean, etc. Now what we want is to actually make the index of this data frame the ID column. Use the setIndex method for that. So now stations, the ID is the index, and then we have our data here. So we can say, take the number of locks for the first 10 stations. We can see how many locks are at each station. Often your data source may have more information than you're interested in, and that can increase memory usage, or it can also just get in your way in various other ways. So you can use drop to remove some of the fields that you don't care about. So axis equals 1 means drop whole columns. Axis equals 0 would mean we're dropping rows. And this is giving us a new data frame with fewer columns. So now it's a bit more concise and only has the information we're more interested in. You could also use the lock accessor to say, give me this view on a subset of the data. Next, we're going to compute some columns. So you can use dataframe.apply to call a function, and this axis equals 1 means call it once for each row. And what this does is we get a function, and it's called for each row in the data frame, and this gives us a new value, and Pandas stores that in a series. So here we've got a function that says, given the row, get the latitude and longitude of the center, and then compute a distance from Oslo center. So Oslo center is this latitude and longitude. This is a formula for, given those two values in degrees, compute the distance, I believe, in kilometers. And now we have a series showing the distance from Oslo center in kilometers. And by treating stations, our data frame, like a dictionary, we can create new columns. If you're assigning with a key a series to a name, that is creating a new column in our data frame. So now we have this distance to Oslo center column, and it's attached to all of our rows. So we can do some exploration of what's the smallest number of locks, what's the largest number of locks, what's the average number of locks, etc. So now we've got all this GPS information and distance from the center and everything. We can use something called IPyLeaflet, which is a tool for visualization with maps and mapping data, including data from OpenStreetMap and a bunch of other sources of map tiles. Since we have the latitude and longitude of all of our stations, we can create a map centered on Oslo center. The zoom level is, you can pick whatever looks right to you. And we're going to use apply again. And this time, instead of doing something with the result, we're just using this to say, for every row, create a marker on the map at the location of the station. And the row.name is going to be the ID index, integer ID, and the title, and then a little HTML pop-up for when we click on the items that'll tell us a little bit about it. So the title of the station and the distance to Oslo center. So here we have a map, and we can zoom around, pan around, and we can click on the stations, and we can see this is station number 253, and it is 900 meters to the center. So sometimes, in addition to concatenation, when you have two sources of different kinds of data that you want to join together, and this is generally called a join or a merge. And where we are right now, we have all our trips with their start and end station and start and end time, and we have our information about the stations. And maybe we want to join those two things together so that we have information about where trips start and end, etc. So a quick example for this. So here's our trip data with our start and end stations integers, and we know we have more information about those stations in our stations data frame. But how do we get those to work together? So a merge says, when we have two sets of information, how do I align them? All right, so how do I tell Pandas that it is the station ID here should be joined with the ID column in the station data frame? So a quick demo, we're going to create two simple data frames, one of purchases and one of prices. We have a price of apples and a price of pears, a number of purchases of apples and a number of purchases of pears. And we're going to join purchases and prices using a right join, and we're joining on the product name. And here we're finding we have a price of apples and pears, and we have purchases of apples and oranges. And when we join, by doing a right join, we're saying find everything we have a price for, and where the product column matches, add a purchase count. So we found apples and pears. We have a price for those. We found purchases for apples. Pears were never purchased, so we get nan. We could tell it to fill that with 0 instead. But you can see the oranges row got dropped because we didn't have a price for that. There are all kinds of tools for how to do the merge to say what happens when it's only on one side or the other. Do you drop it? Do you fill it from both sides? And depending on what kind of data you're working with, all the different choices will let you do whatever you want. There's lots of different ways to combine things. So if we look back to our trip and station data, we have our trip columns and our station columns. So here we have the ID in the station index, and we want the start station column in the trip data frame. So we want to merge trips and stations. We're going to do a left join. We're joining on the left column named start station, and we're joining on the index of the right side. So what do we get when we do this? Here's our start station, and here's our end station. And then we get all the information from the station database. So the title of the station, the number of locks, the latitude, longitude, and the distance to the center. These are all information about the start station. But let's say we want all the same information about the end station as well, just to make sure we have the right amount of rows. So we didn't drop any data. We have information about every start station. If our station data frame had information about less than all of our start stations, this number would be different. But now we want to add the information about the end station as well, but now we're going to have duplicate column names. So the way we solve this is with suffixes. Say where there would be a collision, add start to the left and add end to the right. So now we're doing a join, starting with our merged data. We're doing another left join with the same station database, but this time we're joining on end station and the index on the right-hand side. And this time we have, number of locks, center, etc. for our start station, and title, number of locks, center, etc. for our end station. So I've merged information about the stations for our start station and information about the stations for our end station. So now we can do things like compute the distance from one station to the other. So we can say, how often do people take trips that are more than 5 kilometers, for instance? We can also check out what are the busiest stations by taking the top 5 value counts and making a bar chart. So here are the top 5 stations. But now we can pass the index to this result, which are station IDs, and we can pass those to our station data frame and get information about our top 5 stations. So now, rather than just the opaque 233 and 267, we can see which are actually the busiest stations with information about where they are on a map, etc., that start at that most busy station. We can also resample the data. So resample says create a counter column just with a number and the start time. And then we do resample with every 30 minutes, so T is for time. And this gives us a sum of the number of trips in any given half hour. And then we can say slice this data from midnight on the 2nd of September until 4 a.m. on the 5th. And we can plot and see how many trips started in any given half hour block. And we can see there's a peak in the morning and then a wider peak in the afternoon. But then the next day, we have a steeper peak in the afternoon and not much going on in the morning. And then the following day, it's smoother, more spread out, but mostly over the afternoon. And we can peak. Okay, what is the 3rd? We can see the 3rd is a Saturday. So here you have weekday commute times with a morning peak. And on Saturday, not many people are taking out bikes in the morning. They're all afternoon, leisure trips mostly. And then Sunday is more spread out. So that's our more advanced usage of Pandas, of taking multiple sources of data, joining them, cleaning them up, resampling, filtering, doing all kinds of manipulations and visualizing things on maps and stuff. And that's everything we have to talk about for Pandas.